Hello and welcome to everyone. First of all, thanks for taking the course. I am Shuman Ahmed with you. Just having an Arduino hardware platform is not enough to get your projects working. Besides the hardware, you will also need to write a program to tell the Arduino hardware what to do. In this lecture I will explain the basics of microcontrollers work, how they read and run programs, and how to set up an environment to create programs for your Arduino. At the core all of Arduino units is an 8 mega AVR series microcontroller. The programs that you write to control the Arduino must run on the 8 mega microcontroller. To refresh your memory from the first lecture, 3 basic components reside inside of a microcontroller: the CPU, memory, the input-output interface. Each of these components plays a different role in how the microcontroller interfaces with your project and how you program the microcontroller. The CPU of microcontroller is not all that different from the CPU you would find in your computer. It is just a little smaller size than computer CPU. The several common parts inside the CPU: an arithmetic logic unit or ALU, which performs the mathematical and logical operations data registers. A status register, which contains the status information of the most recently executed arithmetic instructions. A program counter, which keeps track of the memory location of the next instruction to run. A stack pointer, which keeps track of the location of temporary data stored in memory. A controller, which handles loading program code and memory data into the registers, ALU, and pointers. All the CPU components interact within the CPU based on a clocking signal provided to the microcontroller. Each clock pulse, the CPU performs one operation. The speed of the clock pulse determines how fast the CPU processes instructions. For example, the Arduino Uno utilizes a 16 MHz clock, which provides 16 million clock pulses per second. The memory. The Atmel 8 mega microcontroller family uses Harvard architecture for computers. This model separates the computer memory into 2 components. One is the flash memory, which store program code, and another is static random access memory, which store program data. The flash memory retains data after reset the power from the microcontroller, and the program immediately run while power turn on. But static random access memory clear the data while power is reset. Arduino have a separate EEPROM instead of static random access memory for storing data. The EEPROM memory can retain data after loss of power and will not clear until cleared by you. But it is not as fast as the static random access memory. So, you should use it only when you need to save data for later use. The input-output interface allows the microcontroller to interact with the outside world. This allows the Arduino to read analog and digital input signals and send digital output signals back to external devices. The Arduino contains a built-in analog-to-digital converter, which converts analog input signals into a digital value that you can read from your programs. It also contains circuitry to control the digital interface, so that you can use the same pins for either digital input or digital output. All the components work together to process input signals and generate output signals. The CPU controls all the action. Now let's go in programming. The Arduino powered by Atmega microcontroller. So, you should know about the microcontroller programming. You can control the microcontroller CPU using program code. CPU reads the program code instructions and then performs the specified actions, one step at a time. Each type of CPU has its own specific instructions, which the CPU understands, and that's called instruction set. The instruction set is what tells the CPU what data to retrieve and how to process that data. The operations such as reading data, performing a mathematical operation, or outputting data are defined in the instruction set. The instruction set consists of groups of binary data, usually consisting of 1 or 2 byte commands. Actually, microcontroller working by machine code or binary code, which 1 or 0. The machine code is used directly by the microcontroller to process data, but it's not the easiest programming language for humans to read and understand. To solve that problem, Arduino developers have created an IDE that contains additional functions to help make the Arduino programming much easier than coding with machine code. For example, to send a signal to a digital output line, you simply use the digital write function. The IDE includes a full editor for creating your Arduino programs, a compiler to build the finished program, and a method to upload your completed program into the Arduino unit. Creating programs to run on the Arduino is a breeze with the Arduino IDE. Let's installing the Arduino IDE. First, you have to download the IDE from Arduino web page. When you go to that site, you will get Arduino IDE for 3 platforms. Also, you might have noticed that there are 2 download versions for the Windows platform: a standard Windows install file and a zip file. The install file contains both the Arduino IDE and the driver files necessary for Windows to recognize the Arduino when you connect the Arduino via a USB cable. You should download installer file, otherwise you have manually installed the necessary drivers. After you download the installation file, you should find the software. Double-click on the file. Pop up a notifications, click on Agree and Next, and wait for Done. After installation done, you will get an editor environment. In the next lecture, I will explain environment setup, menu bar, serial monitoring, and others. Then write a program for blinking LED. Thanks for with me.